Unexpectedly, Olympus Mons is no longer the highest mountain in the solar system. In reality, the mountains on Earth are the steepest of them and are the only ones where it is occasionally necessary to scale sharp spires and vertical walls. And there is a cause for this oddity. The cause has to do with where they came from. Reliefs are mostly created by the geological process of plate tectonics on our planet. In essence, the Earth's crust is divided into 12 continents, each of which moves like a bumper car track. If the plates do meet, the force will drive the crust to rise along the contact fault, causing enormous amounts of rock to slowly emerge. To create the mountains we see today, wind, water, and gravity work together over millions of years, wearing down, eroding, and sharpening the granite. In summary, tectonics is what determines, over extremely long periods, how mountain ranges form and erode. It also changes various aspects of the planet's environment, and it is always tectonics that contributes to the formation of oceans and land masses, either promoting or inhibiting the emergence of life. It's interesting to note that this specific phenomenon exclusively affects Earth in the solar system. Venus and Mars may have had a similar process moving their crusts, but it was different and has been stopped for hundreds of millions, if not billions of years. Nevertheless, how did the mountains on the other planets arise if they lacked tectonics, atmospheres, or liquid water on their surfaces? If we focus extremely closely, we can claim that there are at least two additional ways that higher or lower mountains can arise. The majority of the reliefs on the Moon, Mercury, Mars, and other rocky bodies are formations with extremely high walls and center peaks that were left behind by comets and asteroids that were able to carve out massive craters. But, in many other instances, it was volcanism that drove the rocks upward as thicker and thicker layers of lava built up over time as a result of repeated eruptions. Well, but what are these mountains of other worlds, someone will ask. How high are they, and where are they located? We're getting there, but first we need to settle on what height really means. As there are no oceans on other worlds, it was decided that the height of those mountains should be determined relative to the plains on which they lay. For example, when we state that Everest is 8,848 meters high, we indicate that this measurement was obtained relative to sea level. An important clarification is necessary because, if this approach is used, Mauna Kea's volcano, not Everest's, will be the highest point on Earth. Mauna Kea is actually just 4,207 meters tall when measured above sea level, ranking it as the 15th highest peak. But if you also take into account the submerged portion, the Hawaiian volcano's overall height is a stunning 9,968 meters, which is 118 meters higher than Everest. Therefore, you shouldn't be shocked if you don't see Everest or Mauna Kea on the list of the highest mountains. In the solar system, competition is really strong. Would you like to start with the top 9? Okay, let's go. Mons, an 11.7 kilometers tall volcano, is in 9th place. The southernmost of the three volcanoes on Mars' equator, Mons, is situated on the Tharsis Bulge. Olympus Mons, the tallest volcano in the solar system, is to the northwest, while Pavonis Mons and Ischrius Mons are located further north. Mons, a monstrous volcano with a base diameter of more than 400 kilometers, is a type of volcano known as a shield volcano, similar to Mauna Kea. A shield volcano is one that often forms from lava flows that are moving. The name refers to the volcanic cone's shield-like profile when viewed from the side. Since its slope is actually very low, less than 5%, it won't be difficult to reach the summit and explore the enormous 110-kilometer-wide caldera in the near future. A white plume was observed coming from the summit of this 50-million-year-old dormant volcano about 2 years ago. Smoke? No, these are just clouds that develop when air rich in water vapor is forced up the sides of a mountain. In fact, the lower temperature at high altitudes causes some of the vapor to condense, resulting in ice crystal clouds. Euboea Montes, who is 12.5 kilometers tall, is in 8th place. On Io, the innermost Galilean moon of Jupiter, more than 135 mountains have been found. The majority of Io's mountains were generated through processes that could be roughly categorized as tectonic, with substantial portions of the crust being shattered, displaced, raised, or sunk by the gravitational tug-of-war that the satellite must experience due to its closeness to Jupiter. As a result, Io's mountains frequently have an isolated, geometric, and skewed appearance. And in effect, this is the situation with Euboea Montes, a mountain that was created after a massive, 200 kilometers long slab was raised and tilted at an angle of roughly 6 degrees. One of the greatest debris aprons in the solar system was created as a result of the uplift's catastrophic slope collapse on the northwest flank. The block's tallest peak reaches a height of 12.5 kilometers. The 12.6 kilometers tall Elysium Mons is in 7th place. Another shield volcano on Mars, but this one has slopes that are 20% or more difficult. Before you reach the peak, you'll have to put in some tough labor. In the eastern hemisphere of Mars, in the province of Elysium, is Elysium Mons. It has a top caldera that is roughly 14 kilometers wide and has a diameter of about 240 kilometers. The lesser volcanoes Albert Tholis to the southeast and Hecates Tholis to the northeast surround it. Is in 6th place. Ionian Mons East Ridge is 12.7 kilometers tall. Similar to many other mountains on Io, this one is also nothing more than a sizable piece of the satellite's crust that was shattered by Jupiter's tidal force before being hurled, dragged, tilted, and abandoned like a massive Lego brick. All of this takes place in a setting that is as lava-filled and hostile as the largest moon of Jupiter's interior. We can be certain of one thing: no group of adventurers will ever wish to attempt to climb such a mountain, not even in the far-off future. 5th placed, Ascrius Mons, 15 kilometers tall. The Tharsis region is home to the massive Martian shield volcano known as Ascrius Mons. Of the 3 shield volcanoes that make up Tharsis Montes, it is the tallest and most northern. It is the second highest peak on Mars and has a base diameter of almost 480 kilometers. With an average slope of 7 degrees, the volcano has a very low profile. The flank's middle region has steeper slopes, which gradually become flatter toward the base and the summit, where a vast summit plateau and a caldera complex may be seen. Busal Montes, in 4th position, is 17.5 kilometers tall. The tallest mountain in Io, Busal Montes, is situated to the northwest of Pele, an active volcano recognizable in images released by probes by the conspicuous ring of red sulfides surrounding it. Busal turns out to be higher than Everest and K2 combined, with a height of almost 17,500. It has the significant distinction of being the solar system's tallest mountain that isn't volcanic. The 20 km high equatorial ridge of Japetus is in 3rd place. The 3rd biggest moon of Saturn and the 11th largest moon in the solar system, Japetus, has a diameter of 1,469 kilometers. It has several distinctive and uncommon features, including a significant difference in brightness between its hemispheres and in particular the enormous equatorial ridge that wraps around the moon in a 3/4 circle. It is a very low-density object made mostly of ice. It is unique to our solar system and has never been observed before. When viewing images of Japetus, one is reminded of a walnut, since the 2 sides of the shell are linked by the traditional raised edge. The amazing structure is 1,300 kilometers long and resembles a mountain range with peaks towering more than 20 kilometers above the surrounding plains. It is on average 25 kilometers wide and 13 kilometers high. There are many theories as to how such an abnormality came to be, but none of them can fully account for all of its characteristics. With a height of 21.9 kilometers, Olympus Mons is in 2nd position. And this one really caught me off guard, as it has been established for years that this enormous volcanic deposit is the highest in the solar system. Were you not also expecting that to be confirmed? But alas, Olympus Mons will have to be content with the podium this time, and going forward, forever. Although it shares the Tharsis region with 3 other Mars volcanoes, this one is a true geological monster. It is the consequence of tens of thousands of extremely fluid basaltic lava flows that over a long period of time flowed from volcanic vents. Also, its base, which has a diameter of more than 600 kilometers, contains an area the size of Arizona. Olympus Mons has a fairly gentle sloping contour due to it being a shield volcano. The volcano's flanks have a 5% slope on average. The flanks have an upward concave profile due to the steeper slopes towards the center and decreasing slopes toward the base. The exceptional size is likely caused by the absence of tectonic plates on Mars, in contrast to Earth. As a result, the crust has remained stable and the hot spot that feeds it has consistently produced lava for millions of years. The escarpment that surrounds the base has sheer walls that range in height from 3,000 to 8,000 meters, making it look like an indestructible castle. It is also very stunning. The first human explorers who want to attempt to ascend the massive volcano will have a difficult time locating a safe entry path. Rhea Silvia's central peak, with a height of 25 kilometers, comes in first. Olympus Mons was still unquestionably the highest mountain in the solar system up until 2011. Then, in that same year, the Dawn probe's encounter to the 525 kilometers in diameter asteroid Vesta abruptly reversed the course of events. In fact, the probe was able to identify the physical traits of a massive impact crater, a surface depression so large, 505 kilometers, that it virtually covered the entire asteroid hemisphere. The remarkable scar was given the name Rhea Silvia after Rhea Silvia, the Vestal Virgin Mother of the founding fathers of Rome in tradition. But there was more. In the middle of the crater rose a mountain that, when measured overall, was roughly 25 kilometers higher than the seafloor. In other words, the tallest peak was ultimately discovered on the tiniest celestial body so far examined. Isn't it wonderful? Let us know what you think in the comment section. Thanks for watching and see you again soon.